For example 2, we're going to find arc cotangent of cotangent of pi over 2. So we want to do the inside first. So I want to find the cotangent of pi over 2. And if I look at the unit circle and I swing open pi over 2 radians, the x-coordinate would be 0 and the y-coordinate would be 1. Since the ratio for cotangent would be x over y, I would have 0 over 1, which would give me 0. So the cotangent of pi over 2 is 0. So that's what I'm going to replace it with. And so now we've got to find the inverse cotangent of 0. And because this is the inverse cotangent, what we want to get out is an angle. For inverse trig functions, we're plugging in the ratio and we're getting out an angle because we switch our inputs and our outputs with the trig functions. Okay, now for cotangent, when we look at the mother function, we need to restrict the domain so that it's from 0 to pi, not including 0 and pi because that's where it would be undefined. And so when we switch our range and domain, for inverse cotangent, my range is now going to be between 0 and pi. So I want to make sure I'm looking at quadrant 1 and quadrant 2 when I'm dealing with inverse cotangent. So I want to look at the unit circle and figure out where I would get 0. What angle would I get 0 for cotangent on the unit circle? And that would have to be pi over 2, because at pi over 2, my x-coordinate is 0, my y-coordinate is 1, so I would have 0 over 1. So my final answer would be pi over 2 for this expression.